Welcome back to RustTalk. Today, we're diving deep into Rust, a language that's known for its unique approach to system programming, and more. We'll be exploring its type system, advanced techniques, and some real-world applications.
That's right, Alan. Rust is a powerful language, and mastering its features is key for writing efficient and safe code. Today, we'll cover everything from basic concepts like ownership and borrowing, to advanced topics like unsafe Rust, concurrency, and real-world applications.
Let's start by talking about the fundamentals. What's so special about Rust's type system?
Well, Rust's type system is like a strict but helpful teacher. It's designed to catch errors at compile time, which can be a bit frustrating at first, but ultimately leads to much more reliable code. We have the primitive types such as integers, floats, and booleans that are the building blocks. And then the compound types like tuples, arrays, and strings that let you combine these. It's like a buffet, but Rust makes sure you take only the specific portions.
And what about ownership and borrowing?
These are at the heart of Rust's memory management. Ownership is like a game of hot potato. A value can only have one owner at a time. Borrowing allows you to temporarily access data without transferring ownership. If you mess up, Rust will give you a compile time error, which can sometimes be long. But it saves you from runtime errors.
Okay, so it prevents those pesky null pointer exceptions, right?
Exactly. Rust uses the option type to handle potential null values, making it a more robust way to deal with the absence of data than allowing a null value that could crash your program. And for error handling, the result type gives you a structured way to return either a successful result or an error, which is a lot more robust than throwing exceptions.
Now let's talk about the more advanced topics. What about unsafe Rust?
Yes. Unsafe Rust. It's a way to bypass some of Rust's safety guarantees for low-level operations, like interacting with C code or manipulating raw pointers. You can use unsafe Rust when you need to squeeze every bit of performance from your code. But you have to ensure that your code upholds Rust safety guarantees manually. It's like having a superpower, but with great power comes great responsibility.
That makes sense. What about traits?
Rust's trait system is very powerful. Traits are like interfaces in other languages and allow you to define shared behavior across different types. Advanced traits include things like associated types, default type parameters, and the new type pattern, which wraps a type in a struct to implement traits or add type safety. Super traits allow you to define dependencies between traits, making your code more modular. They can be seen as superhero powers for your types.
So, traits are kind of like superpowers for types?
Exactly. And with generics, you can write code that works with many different types, like a one-size-fits-all superhero costume.
Now let's talk about types, like the never type.
The never type is used for functions that never return, like panic or loop. It's a small but powerful addition to the type system. Also, there are dynamically sized types DSTs, like star or T, which don't have a fixed size at compile time. They require some special handling, but they make your code more flexible.
What about concurrency? Rust's concurrency model is quite well regarded, isn't it?
Absolutely. Rust's concurrency model is one of its standout features. With async, await, channels, and threads, Rust makes it easy to write concurrent code that's both safe and efficient. The Tokyo library is a very popular async runtime for Rust, especially for networking applications.
Now let's shift gears and talk about real-world applications. Where does Rust really shine?
Well, there are several areas where Rust excels. In web development, Rust has web frameworks like Actix and Rocket for building high-performance web servers. Then, in the blockchain space, Rust is becoming a go-to language due to its performance and safety guarantees. Projects like Parity, Ethereum, and Solana are prime examples. Also, Rust's low-level control and memory safety make it ideal for developing firmware and embedded systems.
What about data science and machine learning?
Yes, Rust's performance and strong typing make it excellent for crunching numbers and training models.
Before we wrap up, any tips for mastering advanced Rust techniques?
Always use tools like Clippy and RustFormert to enforce good coding practices. And don't be afraid to dive into the Rustonomicon, which covers unsafe Rust in detail. It's a must-read for anyone working with low-level code. Also, contributing to the Rust community can be a great learning experience.
Fantastic. It's clear that Rust is a powerful tool, but it does come with its challenges. However, once you get the hang of it, you'll wonder how you ever coded without it.
That's absolutely right. It's like learning a new language, but with more rules. The compiler errors can be frustrating at times, but they ultimately lead to more reliable and performant software.
Well, that's all the time we have for today. Thanks for joining us as we explored the wild world of Rust. If you enjoyed this episode, please subscribe and leave a review.
And if you have any questions or topics you'd like us to cover in the future, drop us a line. Until next time, happy coding. Follow and subscribe AI Alchemist at UKNOW Huab1R.